All right, so here's the idea. I guess the motivation for the paper is an institutional design kind of comparison question. So the motivating thought is that there's a lot of diversity. We came at this, and so I guess thinking about examples from the United States, but there's a lot of diversity quite generally about how executive authority in government is organized. And in particular, the question we're interested in is when you want to take the multiple tasks that an executive has to do and bundle them inside a single elected office, as in, say, the American president, who controls essentially all executive authority. Right? And when you want to unbundle those tasks into multiple elected offices, which is common, say, at the state level in the United States, where you have an elected governor often, as well as an elected treasurer, an elected attorney general, and what have you. Right? So we want a model about thinking about sort of the welfare trade-offs associated with bundling versus unbundling tasks in an accountability framework. So there's the literature. Here's my plan. I'm going to show you a model. I'm going to sort of show you the setup we're going to work with and talk about sort of our approach to the welfare question, and then spend most of my time talking about the equilibrium of the game under the bundling institution, which is sort of the more new analysis, and then I'll go quickly through equilibrium under the unbundling, which is, I think, much more standard and will be fairly easy for everybody to see how it works once you've seen the bundling, and then talk about two kinds of institutional comparisons. And I say that I have conclusions, but I don't actually have any conclusions. All right, so here's the timeline of the game. It's a really simple model of accountability. So two-period model. In the first period, effort is taken on two tasks. Under both institutions, effort is taken on two tasks. Outputs are observed by the voter. Then there's an election. Then there's a second period in which effort is again taken on two tasks. Outputs are observed, and the game ends. So that's the timeline. Really simplest model of agency I think you can have. Right? And the production function is also going to be really, really simple. So the output on task J in period T is just an additive function of three things. Effort on job J in period T, which is A. The task-specific ability, competence of the incumbent for that period. And then some noise, which is everything here is going to be normal distributions. All right? So it's just this additive production function, which is a function of effort and ability and noise. Okay? And importantly, all right, so two important things. This is like a Holmstrom career concerns kind of setup. So all uncertainty is symmetric. Okay, so the politician doesn't know his own competence any better than the voter does. And then importantly, sort of the key sort of assumption that's going to drive everything that's going on is that for a given politician, his two task-specific abilities, task 1 and task 2, right, are imperfectly correlated. Right? So this is the prior distribution on the abilities. So they're distributed each with mean 0, and then there's a variance of 1 and a correlation of rho. So the key thing is that the task-specific competences are imperfectly correlated. That's what it's going to drive all the multitask stuff here. Right? So payoffs in this framework, we're just going to think about a voter who cares about both tasks, but potentially differentially. So he's going to weight task 1 output by gamma, and task 2 output by 1 minus gamma. The voter's not going to discount the future. Right? And here's what officials' payoffs look like. So think about the top is what happens under the bundled institution. That is, bundling means one politician. So there's rents from our office R. So in the first period, you get the rents from office R minus the cost of your two actions. It's important here that actions are separate. I've broken things. Can't take me anywhere. Well, it doesn't, I don't. It's complicated. We'll see if that works. All right, so it's important here that costs are separable. Okay, so that cost function is convex, but we have separable costs, and the reason for that is not because we think costs are actually separable, but this is a multitask model in which we are interested in exploring multitask incentives through learning. That is how the voters' learning process causes kind of multitask incentives. So we want to abstract away from sort of the familiar Holmstrom-Milgram kind of multitask incentives that come through cost complementarity. Right? So sort of the standard intuitions about what drives multitask are going to be assumed away here, and we're still going to get a bunch of multitask kind of incentives, but they're not going to be driven by cost complementarity because we really want to focus in on how the learning causes multitask problems. So we want to abstract away from, we don't want to confuse the matters with also having cost complementarity. So we have separable cost. Okay, and so you have this payoff in the first period, and then if you're reelected, you have similar payoffs for the second period. The rest of the slide is what happens if you unbundle the institution. Okay, so now you have one elected, so what unbundling means is instead of both tasks being done by a single elected official, you have the two tasks separated into two separately elected officials. Okay? And we're just going to assume that now there's a task-specific rent. We're going to impose a budget constraint where the R1 plus R2 has to equal R, so there's not going to be a change in rents across the two systems. And we're going to choose those Rs optimally from the voter's perspective. We're going to choose the optimal unbundling institution from the voter's perspective. Okay? And in order to make any progress on the welfare comparisons, we're going to make a functional form assumption, which is that the marginal cost takes this form of C prime of A is A to the K. Right? So quadratic cost would be K equals 1, for example. All right, so what are we actually going to do? So we want to ask this institutional design question, right, about whether bundling or unbundling is better. And so as I said, right, what we want to do is say we're going to compare the bundled institution, which is already a well-specified game, to the unbundled institution. The unbundled institution up till now is actually a continuum of games because we can choose.
Maybe you should put this in your pocket so that you don't.
Okay.
Yeah.
Okay. All right. I'll try not to break anything else. Okay, so the unbundled institution right now is sort of a continuum institution. So we're going to impose this budget constraint that R1 plus R2 has to equal R. So we're not changing the total rents available to politicians when we unbundle. And then our approach is going to be to look at the optimal unbundled institution. So we're going to choose the one that maximizes voter welfare. Okay. In a model like this, as is sort of common in these kind of two-period agency models, there's actually two aspects of voter welfare which we're going to treat separately. So one is think about first-period voter welfare. Right? Here the voter is presented with a politician who's just a draw from the prior distribution, and is trying to create incentives, is creating incentives for the politician to take actions. Right? So first-period voter welfare is about about sort of two aspects of incentives. One, how strong incentives are for effort, and two, how well aligned incentives are in terms of the division of effort between the two tasks with the voter's weighting of the two tasks. Okay, so that's what's going to determine first period welfare. Second period welfare is sort of common in games like this. In the second period, because it's the end of the world, nobody's going to take any costly effort, but there is a question of how good a job you've done of selecting good types. Right? And that's going to be determined by sort of two things in this model. One, how much information there is, and two, how free the voter is to act on that information given the constraints of sequential rationality. So we're going to treat those two things separately, and then I'll show you when they go together and when they pull in opposite directions. Okay? And the sort of comparative static question we're going to ask with respect to the welfare comparison is how do changes in the voter's preference weights between the two tasks, so how much the voter cares about one task versus the other, and how do changes in the amount of correlation between the task-specific abilities, so in some sense how similar the two tasks are, affect these two aspects of voter welfare and the optimal institutional design. All right, so that's what we're doing. So now I'm going to show you equilibrium under bundling. Is it clear enough so far? All right. Everybody's asleep? Big lunch? I'll tell myself that's the reason. Okay, so let's just think about solving this game from the end. So if you think about the second period, right? In the second period, the voter's expected payoff if he elects politician P is just his weighting of the two tasks times the expected abilities, because the politicians are going to choose zero effort in the second period because there's no electoral incentives, right? So all the voter cares about in the second period is this sort of weighted average of the expectations of the two competences, where the weights are given by the voters' preference weights. Okay? For a challenger, since we've assumed the prior distribution on politicians is mean zero, right? For a challenger, these expectations are zero. And so all we have to do is think about calculating the voters' posteriors about the incumbent, right? And comparing to zero. Right? So this is a normal learning model. So you're going to get these two signals, right? S1 is just equal to A1 plus theta 1 plus normal noise. Right? So suppose the voter believes that the politician took actions A1B and A2B for bundling in the first period. He's going to filter those, right? So S1, which is equal to the true A1 plus the true theta 1 plus noise, S1 minus A1 is an unbiased signal of theta 1, which is the competence that I care about on dimension 1. Right? I'm going to do the sort of standard normal learning thing and take a combination of these two filtered signals. Right? The important thing to see here is the sort of matrix in the middle. Right? So those are the posterior means conditional on outputs and voter beliefs about actions. Right? And the important thing to see here is that matrix in the middle is not diagonal. Right? Which is to say that because there's correlation between task 1 and task 2 competences, in the bundled world, I am using your task 1 productivity to learn both about your task 1 competence and your task 2 competence, and likewise I'm using your task 2 output to learn about your task 1 and your task 2 competence. Right? And how much am I learning it to learn about the other ones? Well, look at the off-diagonal elements. By amount that's essentially proportional to rho, to the amount of correlation. There's the constant out there that has rho in it, so it's not actually proportional to. All right? So this is what's going to drive multitask through learning. Okay? So if I increase performance on task I, that affects the voter's posterior beliefs about both task I and task J competence. Right? And in particular, if you go back and look at the voter's learning and take some derivatives, you'll see the following intuitions, which is the more correlated are the two tasks, the less weight I put on task 1 performance for learning about task 1 competence, and the more weight I put on task 2 performance for learning about task 1 competence. Okay? I don't know what the random citation is. All right. Right? And the idea here is when they're more correlated, right, task I is increasingly informative about task J, and so I'm putting more weight on it. And similarly, when they're more informative, there's a sense in which, think about task 2 performance as acting like a public signal of task 1 ability. And so it essentially, right, it like sort of tightens up the priors with respect to thinking about learning from task 1 output. And so the voter becomes less responsive to task 1 output because he's learning more from task 2. So that's how learning works, and now we can think about the election. So remember, I told you because the priors are mean zero, right? The expected utility of electing the challenger is zero, and so we just have to compare the expected utility of electing the incumbent to zero. So if I think about, I'm going to re-elect the incumbent if gamma times the expectation of the incumbent's ability, where that comes now from that learning we just did, plus 1 minus gamma times the expectation of the incumbent's ability on task 2, where again that comes from the learning we just did, is bigger than 0. Right? Those posteriors that are written as expectations there are just the M1, M2 we calculated on the previous slide. And then we can take that, right, because those posteriors come from filtering these signals, we can move from the election rule in belief space, which is this one in the middle, right, into a re-election rule in outcome space, right, which is just going to say if some weighted average of your performance on task 1 relative to my beliefs about your action on task 1, and your performance on task 2 relative to my beliefs about your performance on task 2 exceeds 0, then I'm going to re-elect you. Okay, so those lambdas are complicated objects, which I think I'll talk about on the next slide. Right? Those lambdas sort of explain why there's a multitask problem here in sense, formally at least, right? So the voter, if you think about just first period incentives, the voter puts weight gamma on task 1 and 1 minus gamma on task 2. However, the politician's incentives put weight lambda on task 1 and lambda 2 on task 2, right? And those lambdas are a function not only of the gammas, but also the rows, right? And the basic idea here is that with respect to incentives in a bundled world, the voter's sequentially rational voting rule doesn't correctly align the politician's incentives with the voter's preferences, because the voter can't help herself from learning about task 1 ability from task 2 output and task 2 ability from task 1 output, right? And therefore taking that into consideration in the learning, and since the voter is forward-looking, not backward-looking, the weights the voter puts in terms of the learning don't equal the weights the voter puts in terms of the preferences. Okay? And that's sort of how you get multitask through learning.
So if rho is 0, the incentives are perfectly aligned?
So if rho is 0,
well, rho 0 means no correlation.
So if there's no correlation, then I believe incentives are perfectly aligned. You might still have strength of incentive effects when you go from bundling to unbundling, but you're not going to have disalignment effects. Okay, so then first period effort. So the voter knows that top line is just from the previous slide. That's the re-election rule. I get re-elected if that's true, right? Remember, A1B and A2B, those are the voter's beliefs about the politician's effort. Those will be correct in equilibrium, but at this point they're not correct. They don't have to be correct yet. So the voter says, well, suppose I choose efforts A1 and A2. Then the left-hand side there is just a normal random variable, right? Because you've got the thetas and the epsilons, which are both mean 0. Right? So it's a normal random variable whose mean is lambda times A1 minus AB plus lambda 2 times A2 minus AB, and some variance. And so from this, the voter can calculate his probability of re-election conditional on any choice, given the beliefs of the voter and the learning rule. Right? And so from that, you can just write down the voter's probability of re-election. So this is the CDF of the normal distribution. Right? So if I get an outcome that's higher than that thing, right, where thing is mean 0, then I'm going to get reelected. So if I choose A1, A2, my expected utility is the probability I get reelected, which is the thing in brackets, times my rents from office, minus my 2 costs. And you can take derivatives and then impose that beliefs have to be correct to get first order conditions. Okay? And that's what that's the key equilibrium condition in the bundled world. Is that, we good? Right. So under unbundling, everything's the same except much, much simpler, because when you unbundle, you break all the correlations. Right? And so now I observe task 1 effort. That's an unbiased, when I filter out my beliefs about action, that's an unbiased signal of task 1 ability, and completely uninformative about task 2 ability, because the task 2 politician's a different person and they're independent. Okay, so you're going to do all the same things, right? But you're not going to have to worry about the correlations, right? So the voter's expected payoff is still just gamma times the expectation of the first task 1 politician's expected ability plus 1 minus gamma times the expectation of the task 2 politician's ability. But now those things don't interrelate anymore, and so I re-elect you if and only if, right, some lambda that comes from a standard normal learning process times your outcome is better than 0, and I don't have to worry about the other dimension. Well, that's not a very informative slide. All right. So again, we can in exactly the same way we can calculate the probability of re-election conditional on an outcome given the voter's belief. If you're the task J incumbent and the voter believes the task J incumbent is going to take action AJU, you get re-elected if your outcome makes this thing positive, right? And that thing again is just a normal random variable with mean AJ minus AJU times lambda. And you get something that looks exactly the same, only simpler because you don't have to worry about any of the correlations again, right? That lambda doesn't have any rows in it. So you get the probability of re-election times the rents from office, where again, remember now the rents from office are the task J specific rents from office. And you get a similar looking first order condition. Okay? So the last step the last step for the unbundled case is we want to choose the correct division of rents for the voter. So we're going to let the voter or the institutional designer choose the division of rents to maximize voter welfare. So we're going to ask the question when we do our institutional comparisons, is the bundled, when is the bundled institution better than the best of the unbundled institutions? Right? So the sort of key step in making that go is to notice that the voter's second period welfare in the unbundled institution is independent of how you divide those weights. Okay, so we're going to call eta the amount of R that you give to task 1. And the basic idea here is you're just getting this additive signal. So the informativeness of the signal is not a function of how hard you work. Right? And therefore, when I change the amount of rents you get from holding office, that's going to change how hard you work, but it's not going to change the informativeness of the signal. And when we get to the election, all I'm doing is voting on the posterior mean, which is going to be constant in those things, and therefore I can ignore second period voter welfare when I do this optimal choice. I can just choose it to optimize with respect to first period incentives. Is that because there's no interaction between effort and time? That's right. If they were multiplicative, this would be false. Right? If they were multiplicative, then the harder you work, the lower the variance of the signal would be. Okay? So I can just think about first period welfare. And if I choose the eta that maximizes first period welfare, the division of the rents that maximizes first period welfare, I will have maximized total voter welfare. And so the functional form is what gets us a closed form for this, which is going to be helpful for the comparisons. Right? So those are the two equilibria, and now I'm just going to ask institutional comparisons. Okay?
So this is the first time that you used
That's the first time I used, yes, that's right. That's the exponential cost functions, yeah. But it is going to be important for the comparative static. I mean, we are definitely going to lean on it. Okay, so now the plan is, right, we've got these two institutions, we know what equilibrium looks like in each of them, and we can ask which one's better. But asking which one's better, right, depends on there are these two aspects of voter welfare. There's the first period power of incentives and alignment incentives question, and there's the second period quality of filtering and freedom to filter as you like on the 2 dimensions question. We're just going to treat those separately because we don't want to sort of take a stand, right? We could have a discount rate and let it arbitrarily go from 0 to infinity since the second period represents the entire future. And then we could actually sign these things, but that doesn't strike us as particularly interesting. And so what we're going to do is just leave them separate and be able to say, you know, when is one good for first period, when is the other good for first period, and we can see sometimes there's a dominant institution and sometimes there's a trade-off between how much you care about first period and second period. Okay, so I'm going to start by talking about first period. So what this result says is that before I get to comparative statics, before we get to comparative statics, we start by proving a result which says that either institution can be optimal. That is, there exist parameter values such that either institution is optimal with respect to first period voter welfare. So there's not a dominant institution with respect to first period welfare. And in particular, what the proposition says is if gamma is extreme, so that is if the voter cares only about one task and not the other, and there's any positive correlation, then you prefer unbundling. Okay, so if the voter cares a lot about one task and not about the other, and there's any positive correlation, then you prefer unbundling. And if gamma is central, then you prefer bundling. I'm going to show you more general comparative statics than that, but this is sort of the existence of either one can be dominant.
So are you going to say something about lambda in between?
Yes, I am. It's going to be smooth. I'll show you.
No, my best guess is that the extremes are very different than anything in the middle, right?
Yeah, I'm going to show you the middle. As best I can, at least. Okay? So the intuition here. So let's think about the case of, I think a lot of the intuition for the comparative statics comes about thinking about these extremes. So think about the case of extreme preference weights. Okay? This is the world in which the voter is going to prefer to be unbundled. Right? So when you have extreme preference weights with respect to first period voter welfare, what the voter wants the politician to do is focus on the task. So suppose the voter only cares about task 1. What the voter wants the politician to do is focus only on task 1. Right? In the bundled world, because of the correlation, the voter cannot shut down incentives on task 2, even though the voter doesn't care about task 2, because the politician knows that the voter is going to be learning about task 1 competence from task 2 performance. And so suppose the voter believed the politician would do nothing on task 2. Then the politician would have, right, in the standard career concerns way, incentives to do lots on task 2, fool the voter into thinking he's really good, which would have good implications for his task 1 beliefs, the voter's task 1 beliefs, which would increase the probability of re-election. Right? So that's the problem. So bundling in the presence of positive correlation means that even when the voter doesn't care at all about one of the tasks, the voter can't shut down incentives on that task. Yeah?
So costs are a function of the total effort instead of the separable
Yeah.
model. So then this logic wouldn't work, right, if I understand.
No, I think this logic would still work.
So here, with bundling, the guy is going to exert exert effort on action 2 because the marginal cost is 0, right? Or is it not?
No, I mean, so imagine that they were all inside a single convex cost function. The logic I said still holds, right? Which is that if the voter expects you to do 0 effort, right, a little bit of effort is going to surprise the voter in a way that's going to make him think it's all about competence. So if the marginal costs are big enough that you don't do effort on anything, that's right.
But in John's model, you have a race between your correlation and his
Yes, I think you might have a race between the amount of correlation and the amount of marginal cost. And what I want to think about is whether that's really true or whether the first step of beliefs is big enough that you don't have to worry about that. I'm not sure whether that's first order or not. But it's certainly not the case that non-separable cost is going to do away with the intuition of this result, although you might have a race between the amount of correlation and the amount of and the marginal cost.
So if you had negative correlation or variables, then you actually would be able to put down incentives on the unimportant tasks.
That's right. If you had negative correlations, I want to convince you that I'm bad. I want to perform badly on task 2 so that you think I'm good on task 1. Here we've restricted to positive correlation.
Yeah, so the first step in this argument says the incentives actually shut down on the unimportant tasks.
Yeah.
So here, I suppose that you will not spend as much effort on task 1 because there will be some less underlying uncertainty.
I think in a world of negative correlations, you're going to do nothing on task 2.
Right, but less on task 1 anyway.
You mean just because of the presence of an additional signal? Yes, that exists no matter what. The presence of an additional signal on task 1 just always reduces incentives for work. Yep.
The intuition that you're explaining would get even stronger in n tasks, smaller, right?
So I don't have an intuition that it gets stronger. My intuition is it doesn't change, at least for separable costs. For any task, when you're at the low part of the marginal costs, if the voter believes you're going to do 0 effort, you want to do some effort to fool the voter. All right, so that's why you prefer unbundling, is because unbundling allows you to basically, right, when you have these extreme beliefs, because we're looking at the optimal unbundling institution, you take all the rents, give them to the task 1 guy, say the task 2 guy, I'm just not going to give you any rents. That shuts down incentives and lets you focus everything on task 1. Right? That's not going to be true for second period welfare with respect to this same comparative static, but it is true for first period welfare. Okay? The intuition for equal weights is not quite just the opposite, so I wanted to talk about it. Right? So the intuition for equal weights is this. Total effort is going to be lower under unbundling. And the reason is because you're dividing the rewards to office. We have these separable costs. You're dividing the rewards for office, so you're going to get lower total effort out of the 2 politicians than you would if you bundled them. Right? But that's one effect, right? So that tends to make, when you have relatively equal preference weights, so you care about the 2 tasks, that tends to make bundling better. But there's an offsetting effect. The offsetting effect, which is going to turn out to be second order, but is an effect, is exactly the intuition that Georgi said, which is that when you have bundling, there's the presence of an extra signal about your ability, which just reduces incentives. Right? If you think about the incentives to engage in task 1 effort, it's essentially scaled by the amount of probability mass you're moving past the electoral threshold by a marginal increase in effort. Right? When you have an external signal about your ability, right, That's like a public signal, right? And so the voters' posteriors become less responsive to changes in task 1 performance, and therefore the amount of probability mass you're moving is smaller, and you get weaker incentives. It turns out that effect is second order relative to this one, and so when you have equal preference weights, bundling dominates.
Yeah. Probably it's not particularly relevant for the exercise that you're doing, just out of curiosity. There is negative correlation, you always want to unbundle.
If there's negative correlation, you always want to unbundle. I don't think that's going to be true.
Okay.
So when you have negative correlation, it's true that you get this effect that you want to perform badly on the task that he cares less about, but you also get this total effort effect. So I'm not so sure. All right, so now you can do comparative statics. So that's sort of the sort of big intuition underlying what's going on. All right, so the comparative statics are the more highly correlated are the competences, so the more similar the tasks are in some sense, right? The less likely bundling is to be optimal with respect to first period voter welfare. So the more similar the tasks are, the more likely it is with respect to first period incentives to be optimal to divide the tasks. Okay? And so the reason is, right, that as we've already talked about, under bundling, this correlation drives this wedge between voter weights and politician incentive weights, right? And unbundling eliminates that distortion. The more correlated the tasks are, the more that distortion looms large, and so the more willing the voter is to give up the total power of incentives to get the better alignment of incentives. Okay? So correlation is bad from the voter's perspective with respect to first period incentives. Okay? Under bundling. And the comparative static on preference weights is complicated, so I'm going to tell you about a limiting case where we have analytical results. And then I'll show you some computations that suggest they're the same under the non-limiting case, but I can only give you analytical results for the limiting case. So the limiting case is quadratic costs. Okay, so k equals 1. Right, and the essential problem is there's two competing effects in terms of the comparison of welfares. Okay? So notice that under quadratic costs, so in this limiting case, you're going to get a corner solution under bundling, regardless of gamma, unless gamma equals 1/2. Okay, so generically, you're going to get a corner solution where all rewards of office go to the more important task when you unbundle. Okay, so now think about the first effect. Okay, so under unbundling, you're getting, let's say the voter cares more about task 1. You're getting all of the incentives under unbundling on task 1, whereas under task 2, whereas under bundling, you get a mix. Okay, so as the voter becomes more focused on task 1, the voter's preferences are moving into better alignment with behavior under unbundling. Right? Behavior under unbundling is this corner solution. It's just fixed where it is. As the voter moves more and more towards only caring about that task, the voter's incentives are moving into alignment with the politician's behavior under unbundling. Okay? So that's effect 1, and that tends to make unbundling more attractive as the voter becomes more extreme. Okay? The second effect, however, is that as you make the voter more extreme on in terms of caring about one task, under bundling, the voter, although imperfectly, is also becoming more focused. The politician, although imperfectly, is becoming more focused on that task, whereas the politician's behavior under unbundling isn't changing because it's a corner solution, and that tends to make the voter like bundling better. So there's already these two competing effects, even in our limiting case where we get a corner solution. The one is the voter's preferences coming into alignment as he becomes more extreme with unbundling, and the other is the politician's behavior moving towards the voter's preferences under bundling as the voter becomes more extreme. These are offsetting effects, which by a miracle, I will say, we can sign in the limiting case. Right? So in the limiting case, it's always going to be the case that, that bundling is optimal only on a central region of gammas. Right? So only for voters sufficiently close to caring about both tasks. Right? I don't have an intuition for you about why the first task is dominated by the second task in this limiting case. It is true, but my intuitions fail me. So if we move away from the limiting case, two things happen. One, those two competing effects become much harder to sign because now you don't have a corner solution in the unbundling case. So both things are happening to both institutions as you move gamma, and we can't even sign those two effects. In addition, there's other indirect effects, and so I don't have a proposition for you about the non-limiting case, but we've done lots of computation, and we always get a very beautiful thing that looks exactly like it's sort of supposed to, which is that, so the x-axis here is the amount of correlation, the y-axis is the gamma, the weight on task 1, right? And the blue region is where bundling is optimal, and the white region is where unbundling is optimal, all with respect to first period incentives. And what you see is for lots of k's, as rho increase, so it's for any rho, it's the case that that bundling is optimal only on a central region of gamma, and that region is decreasing as rho gets bigger. But that's computation. We don't have a proof for you of that. Right? So there's, we think, kind of a cute interpretation of this result, which is that, at least with respect to first period incentives, when one task is significantly more important than the other, then what you want to do is create with respect to first period incentives, you want to create a hierarchy of offices. Each specializes in one task, and the more important task gets significantly more rewards of office than the other. Right? When tasks are of roughly equal importance, you want to create a single office with multiple responsibilities, but it's never optimal here to create multiple offices of roughly equal import. Okay? So you got like the governor and the secretary of state, but you never have like sort of the two governors.
So in what sense this is a hierarchy? I mean, only because the rewards are different.
Yes, only in the, there's no, that's right, there's no supervisory, that's right. Hierarchy is probably the wrong term. I'll blame Scott.
So the consul was not
At least with respect to first period incentives. Not so much with respect to selection.
Okay.
Yeah.
So another way to interpret this interpretation is if there was like one task and there was a guy who had an office, then you add one very unimportant task to him. So instead of doing so, you would rather create a separate office for the unimportant task.
That's right. At least with respect to first period incentives.
Which is counterintuitive. You probably think that, well, if it's an unimportant and minor task and doesn't consume too much.
So that's probably because you think there's fixed costs of establishing the task, which we don't have here. Of establishing the office. I think the reason it's counterintuitive is we have in mind, well, we got to hold an election and have an office, and we don't have that. So certainly if it's sufficiently unimportant, those fixed costs are going to dominate this, right? All right, so how am I doing on time? Oh, fantastic. All right, so let me talk about second period welfare, where I have results for all the comparative statics. All right, so second period welfare is going to be driven here by how well you're doing at selecting good types, where there's going to be two aspects to that now, as opposed to sort of the standard one action model where there's just how well are you doing at selecting good types. Here it's going to be both a function of how much information is available, right, but also how flexible the voter is in being able to use that information. And that's already going to set up a trade-off between bundling and unbundling, because in the bundling world, there's going to be more information available because the correlations mean that you're getting extra signals about each task, right? But the voter is going to be less flexible in his ability to use the information he has, because if he observes, for example, that the incumbent's really good on task 1 and really good on task 2, he has to keep or leave the incumbent on both tasks, right? Whereas under unbundling, if I get a good guy on task 1 and a bad one on task 2, I can swap out this one and keep this one. So there's going to be a trade-off between voter flexibility and the amount of information. All right, so again, we have a result that says either institution can be optimal. All right, so there exist parameter values such that either institution is optimal with respect to second period. So this is, I should be clear, we're talking here about ex ante expected second period welfare. Right? So not at the time of election, but at the beginning of the game. Right? So if the correlations are sufficiently small, then unbundling is going to be preferred. And if the correlation is sufficiently large, then bundling is going to be preferred. And again, I'm going to show you two sets of comparative statics. But first, let me talk a little about that intuition. Right? Well, I guess this is exactly what I said. I'm not going to talk about this slide because I already said it. This is exactly the trade-off that I just talked about. All right. So let's talk about the comparative statics. So here's a comparative static on the correlations of the competences. So the more highly correlated are the competences, so the more similar are the two tasks in some sense, the more likely bundling is to be optimal with respect to ex-ante expected second period voter welfare, right? So what's going on here, right? Two things. So as you increase the correlation, you're simply increasing the amount of information available to the voter under bundling, but having no effect on the amount of information available to the voter under unbundling, because under unbundling the correlations don't matter, right? So that already pushes in the direction of unbundling being good. I'm sorry, bundling being good. And there's a second effect, which is as the two competences become more highly correlated, you are less and less likely to be in that situation I described of having a guy who's really good on task 1 and really bad on task 2, because after all, the two tasks are highly correlated. So not only do you get more information, but the bad side of bundling is becoming less and less likely, right? So both of those things are happening at once, which means that increasing correlation is all good for bundling, and so you get a clean, as correlation increases, bundling is better with respect to second period welfare, right? And with respect to preference weights, the further from 1/2, so that is the more extreme, because remember this gamma is the weight on task 1, so it goes from 0 to 1, and 1/2 means exactly equally divided, and away from 1/2 in either direction means focused on a particular task. So the more focused the voter is on a particular task, okay, the more likely bundling is to be optimal with respect to second period welfare. Right? So more extreme voters like bundling better. Why? Well, so when you change the voters' preference weights, there's no effect on information, right? So the informational environments in the two systems stay the same. But as the voter cares more and more about, say, task 1, right, holding fixed everything else, the voter finds himself less and less likely to be in the situation of facing this trade-off where I've got somebody who's good on one dimension and bad on the other dimension, and I have to decide what to do. Because after all, if I only care about task 1, I've got the extra information that comes from the bundled environment, and I face no trade-offs because I just focus entirely on task 1. So the more extreme I am, the less the cost of bundling binds on me, and the more willing I am to bundle. Right? So in the case of second period welfare, you get a picture like this. Again, the x-axis is the correlations, the y-axis is gammas. So this is computation in some sense, but these are just representations of the analytic results I just gave you, which is fix a gamma. As rho gets bigger, it becomes more likely that bundling is optimal because there's the more information and the better alignment. And fix a rho, as gamma moves away from 1/2, bundling becomes more likely to be optimal because the voter doesn't face this disalignment problem. All right, so here's my conclusion. I can put the two pictures together, right? And at least if you'll grant me the limiting case or the one computation, I have the following. I have a summary of sort of characterization of optimal institutions under this model, right? Which is that you have situations where there's a dominant institution for both things, right? So in the white spaces there, unbundling is optimal. So this is the voter's very extreme with respect to what task he cares about, and the correlation is relatively low. And here you like unbundling, right? Or in a world where gamma is fairly centrist and rho is very high, you like bundling. Elsewhere in the parameter space, however, there's a trade-off between choosing the institution that's good for the voter with respect to incentives and the institution that's good for the voter with respect to learning. Right? There's in this model, there's always this tension, which is like, as I move gamma away from 1/2, right? On the one hand, I like unbundling better with respect to first period incentives because I can align incentives better. Right? But as I move gamma away from 1/2, as I make the voter more extreme, I like bundling better, with respect to selection because I don't face the downside of selection. Similarly, as I make correlation bigger, right, I tend to like unbundling better with respect to first period incentives because as the correlation gets bigger, the disalignment gets bad. But I tend to like bundling better with respect to second period selection because there's more information in that effect. So there are there's the gamma and the rho comparative statics point to fundamental trade-offs between first and second period welfare with respect to both of these parameters. And it turns out sometimes things work out so they go together, but often there's trade-offs in terms of what part of voter welfare you care about in terms of characterizing the optimal institution. So we think there's some potential applications. I talked about organization of local government, which my colleague Chris Berry has worked on a fair bit. We think there's an interesting application to federalism where I think the model's the same, but the welfare implications are actually quite different in an interesting way, which is if you think of this as a model of federalism where there's like region 1 and region 2 activities, the sort of overall welfare is the same. You weight by the two region weight, where the gammas are now the size of the populations. You're doing right by weighting by those in the voter welfare, but the politicians' incentives now may come overwhelmingly from the larger region, right? And so, if it's sort of under the bundled system. And so you face the same model with the same sort of welfare, but sort of different behavior by politicians, because if one region's much bigger than the other, the politician's just going to only respond to that. And so we think there's something interesting there, which we haven't done, but we think it might be interesting to think about federalism in this setting.
So you've unbundled the first period voter and the second period voter, but you think of a representative voter with discounts the stream?
Yeah, so here's my takeaway from this picture, and I think of this as sort of like the thing they do when they do these kind of welfare comparisons in IO too, which is that I have these two trade-offs, and now you tell me the discount factor for your particular application, right? But I don't think the discount factor here should be bounded between 0 and 1, because the second period is supposed to represent all of the future. And so I don't want to, obviously if I choose delta sufficiently small, then I have an answer, and if I choose it sufficiently large, I have an answer. But I don't have sort of a priori reason. So I think of this as doing that, only not trying to.
Weighting is an alpha weight for today and 1 minus alpha for tomorrow. If alpha is less than half, that's like having a longer horizon.
Yeah.
So, it seems like if you have a long horizon, so the weight on the first period is relatively low. It sort of seems like whether bundling is optimal or not depends.
That's right.
It's even depend primarily on rho, right? On how much you're learning, right? If you're learning, right?
For this particular choice, exactly how big these various regions are is going to depend on your choice of K also. So for this picture, that's right. Though I could make them move around. But I'm always going to have this shape.
The
But
pictures didn't seem to change a lot with K. The earlier pictures.
so I think that's a question we could ask: is how much structure we could put on if we put alpha and 1 minus alpha weights, how much structure we could put on the answer.
Because intuitively it would seem like you care about the long run learning that you're getting. So you want to read sentence to learn more.
So
If you care about speech, maybe not.
Of course, if you thought about the proper repeated elections model, you'd have incentives and learning in both periods. John is nodding. It's like, the hell is this 2-period model of elections? It's ridiculous. Fair enough.
Other questions? Or better move on.
Thank you very much.
Thank you.